Hello students, today we are going to start new chapter, thermal properties of matter. See, we all have the common sense of notion of heat and temperature. See, temperature is a measure of hardness of a body. In physics, we need to define the notion of heat, temperature more carefully. In this chapter, we will learn what is heat and how it is measured, and the study of the various process by which heat flows from one body to another. Along the way, you will also learn that what happens when the water boils or freezes and its temperature does not change during the process. This and all we are going to learn. Even though the great deal which heat is flowing in or out. Let us see elaborately, students. Yes, students. What is heat and temperature? Through the definition we can see heat. It is a form of energy which produces in us the sensation of hotness or coldness. That we can say, according to this dynamic theory, the heat may be regarded as the energy of molecular motion, which is equal to the sum of the total kinetic energy which is possessed by the molecules by virtue of their translational, vibrational, rotational motion. So that we can say that is a heat, is a sensation of hotness or coldness. Temperature. We know that it is a degree of hotness or coldness of the body. See, this is the degree of hotness or coldness of the body, we said. We can say the thermal state of the body which decides the direction of flow of heat energy from one body to another or placed in the thermal contact with that. And heat is the energy in transit. We can say that it flows from one body to another due to the temperature difference between them. See, this is the part of the internal energy that transferred from one body to another due to the temperature differences between the heat, right? The SI unit and the CGS unit of heat. So, the heat, we know that the heat is the energy which is required to raise the temperature of 1 gram of water through 1 degree Celsius. That is, for CGS unit of heat is calorie, SI unit of heat, joule, as we know, right? So, it is a joule, like all other form of energy for heat, SI unit is joule. And joules is a mechanical equivalent of heat. See, that we can say, whenever a given amount of work, the W, is converted into heat, that is always the same amount of heat which is produced. So that we can say W, the work which is equal to Q. Or else we can say W which is equal to J into Q. Or joule J which is equal to W by Q. That is only we have said the heat energy which is required to raise the temperature of 1 gram of water through 1 degree Celsius, that is the CGS unit calorie, SI unit is joule. And 1 joule which is equal to the value of 4.186 joule per calorie. Or in the CGS unit we can say that 4.186 into 10 to the power of 6 ERG per calorie, that is erg per calorie. So thermometry, see, it is a branch of physics, deals with the measurement of temperature. And thermometer, as we know well, it is a device used to measure the temperature of a body which is called thermometer. The principle of thermometer, we can say, so it makes the use of some measurable property that we can say called as a thermometric property of a substance It helps to changes the linearly with the temperature. See, some of the thermometric properties are length, volume, pressure, the electrical resistance, that and all we can see. So we are using usually the liquid is mercury or alcohol. We have the fixed point on a temperature scale, that is, we have one is the temperature which helps in the lower fixed point. That means the temperature at which pure ice melts at a standard pressure, that we can call as a lower fixed point. The upper fixed point, which is nothing but the temperature which helps the pure water boils at the atmospheric pressure, that we can call it as upper fixed point. So different temperature scales and their important features which you are seeing on the screen. These are all the temperature scales: Celsius, Fahrenheit, Thermometer, Kelvin. See, for the Celsius you may see that lower fixed point, that is the melting point of the ice, is 0 degrees Celsius. Whereas the upper fixed point or the boiling point of water, we can say that 100 degrees Celsius. For Fahrenheit, the melting point is 32 degrees Fahrenheit and the boiling point of water is 212 degrees Fahrenheit. Then next one is the thermometer, that is a 0 degree thermometer. To the boiling point is a 80 degree thermometer. Kelvin, that we can say that 273 degree Kelvin, and for boiling point it is a 373 Kelvin. Right. The diagram they have given clearly that ice point for Celsius, Fahrenheit, thermometer and Kelvin, right? So water boiling point, the ice point. See the lowest possible temperature, students. That is for Celsius, it's minus 273 degrees Celsius. Fahrenheit, minus 459 degree Fahrenheit. And for thermometer, we can say minus 218. For Kelvin, the lowest possible temperature, 0 Kelvin. Right. So these are all the different temperature scales and their important features you must know. Conversion of temperature from one scale to another. To convert the temperature from one scale to another, see the following relation is used. Temperature on one scale minus lower fixed point whole divided by the upper fixed point minus lower fixed point. That means we can say the temperature, the differences between the temperature on the other scale to the lower fixed point whole divided by the differences between the upper fixed point and the lower fixed point. As we are seeing the diagram before, right? If the temperature of the body is measured as T Celsius, that means the temperature Celsius, or the temperature in Fahrenheit, or maybe that is Kelvin, on that the scale respectively if you have taken, then we can say Tc minus 0. That means the temperature on one scale. For example, I have taken here the temperature on one scale is Celsius. So T Celsius minus 0 whole divided by the upper fixed point, what I have showed there in the Celsius, 100, right? 100 minus 0. In that same way, I have given for the Fahrenheit and Kelvin also, right? So, Tc minus 0 whole divided by 100. We can say we need to convert the temperature from one scale to another, which we are using for the Celsius means. We have to use the formula Tc minus 0 by 100. That same way we have to use it for Fahrenheit, Tf minus 32 whole divided by 180. The thermometer, we can use Tr minus 0 whole divided by 80, which is equal to the Kelvin Tk minus 273 whole divided by 100. So this helps to know the conversion of temperature from one scale to another. the advantages of using mercury as a thermometric substance as compared to other liquid. So actually it has a uniform coefficient of expansion. That is, over a wide range of temperature, it has the uniform coefficient. The next one is, we can say that opaque and bright. See, mercury actually it is opaque and bright, so that only its level can seen easily in the glass tube. The next one is, it does not stick to the walls of a glass tube. And actually it is a very good conductor of heat, and because of that it attains the temperature of hot body very quickly. It has the low specific heat, so that only it absorbs very small amount of heat from the body whose temperature is to be measured. That's why we are using mercury, students, as a thermometric substance. Absolute zero and absolute scale of temperature. See, according to Charles' law, we can say that Vt and V0. So the relation of Vt and V0 we have given here. That is for the given mass of the gas, that is Vt, which is equal to V0 into 1 plus T by 273.15. See, we can get that clearly. The volume of the gas below 0 degrees Celsius will be less than V0. For example, the volume of the gas at minus T degrees Celsius means we can write that Vt of minus, that is V of minus T, right? V of minus T, which is equal to V0 1 plus T by 273.15, right? That we can say. So here we have written 1 plus because of the minus, so 1 minus T by 273.15. Observe the graph, this graphical representation which is for the volume of the gas as a function of temperature. See, the decreases of the temperature will give the resultant of decreasing in volume of the gas. We are plotting, as we said, the volume of the given mass of a gas against the temperature of a constant pressure. If we extrapolate the straight line graph, it meets the temperature axis at minus 273, students. See, it is there minus 273 degrees Celsius, so that the gas occupies 0, or we can say there is no volume at minus 273 degree 15 Celsius. So from this we can get clearly that the temperature below minus 273.15, it is not possible, right, for the gas. So because gas would be, that volume of gas would be negative, which means it is a meaningless one. So that it is impossible actually. So T of K, that is temperature of Kelvin, that is equal to T small t 0 degree Celsius plus 273. That we can say the size of the degree of Kelvin scale is same as the Celsius scale, right? The next one is thermal expansion. See, the thermal expansion, which is nothing but the increase in the size of the body when it is heated, which we can call it as thermal expansion, right? So, the different types of thermal expansion, we can say linearly expansion and superficial expansion, cubical expansion. So, linearly, which means it is one dimension, we can say it is the increase in the length of the metal rod while it is heating. And this superficial, we can say it will give the increase in the surface area of the metal rod. The cubical expansion, we can say that the increase in the volume, right? So it is increasing the volume of the block on heating. Yes, students, so far we have learnt from this session temperature and heat, measurement of temperature, ideal gas equation of absolute zero temperature, and the thermal expansion. Thank you, students.